Hello Year 10. Today what we're looking at is continuing non-right angled trigonometry. We're going to look at miscellaneous problems today in exercise 1508. So when solving miscellaneous problems, we need to identify which trigonometry rule should be used. So if we have a right angle, we use SOHCAHTOA. If we have two angles and two sides, we use the sine rule. And if we have one angle and three sides, we use the cosine rule. Let's review SOHCAHTOA. So for SOHCAHTOA, we need a right angle triangle, and it's important to remember that our hypotenuse, when labeling our right angle triangle, is opposite our right angle. Our opposite side is opposite our angle that we are given, and our adjacent side is next to our angle. We have three trig ratios, the first one being sine, and sine theta equals the opposite over the hypotenuse, which equals O over H. We have the cosine ratio, which is cos theta equals the adjacent over the hypotenuse, which equals A over H. And we have the tangent ratio, which is tan theta equals the opposite over the adjacent, which equals O over A. Let's review the sine rule. So to find any side or angle in the sine rule, it's important to first look at the triangle. We can use the sine rule in any type of triangle where our angle A is opposite our side A, our angle B is opposite side B, our angle C is opposite side C. So to find a side, our unknown side is first on the top here. So we'll have A over sine A equals B over sine B, which equals C over sine C. And then to find an angle, our unknown angle is the first thing on the top here. So we have sine A over A equals sine B over B, which equals sine C over C. Whenever we are using the sine rule, our unknown is always the first thing here, and our sine rules to find a side and to find an angle are just the reciprocal of each other. Let's review the cosine rule. Again, with the cosine rule, we can use this in any triangle. And again, our angle A is opposite side A, angle B is opposite side B, angle C is opposite side C. So to find a side, we use the rule A squared equals B squared plus C squared minus 2BC cos A. And to find an angle, we use cos A equals B squared plus C squared minus A squared over 2BC. Now, how to look at whether you should use the sine rule or the cosine rule. If we go back to the sine rule, when we're using the sine rule, we don't really use this C side here. We only really need two sides and two angles. So when we are doing that, I like to draw a line from the angle that I know across to the side that I know, and the same with the other angle and side. If I can draw an X like so, that means I want to use the sine rule. So an X equals sine rule. For the cosine rule, what you should have is three sides and the included angle like so. And there's no really trick for this. It's just important to know that. Let's look at some examples. So we are going to identify whether we should use SOHCAHTOA, the sine rule, or the cosine rule to then find the value of the pronumeral correct to one decimal place. So there's two steps to this question. So what we want to do is we want to work out whether you're using SOHCAHTOA, the sine rule, or the cosine rule. So what we can do is we can eliminate SOHCAHTOA straight away. The reason why we can eliminate SOHCAHTOA straight away is because we do not have a right angle given to us in our triangle. Now, to work out whether we're using the sine rule or the cosine rule, we need to work out how many angles and sides we have. So we have 1, 2, 3 sides, and we are given one angle. So because we have been given 3 sides and 1 angle, we therefore must use the cosine rule. Now, the cosine rule that we are going to use for this one is the one to find a side. Why are we using the one to find a side? It is because the side is unknown. So the cosine rule to find a side is a squared equals b squared plus c squared minus 2bc times cos a. Now, what I'm going to do is I'm going to highlight my values that match up. So, our A angle is always where we have our angle given to us for our cosine rule. So that is A here. That means this opposite side is side A. Now, it doesn't matter which vertex, either this one or this one, you call B, and the other one is just called C. So I'll just call this one B and this one C. So that means that our 27 must be side B and our 19 must be side C. Now that we know this, we can substitute all of our values into our equation like so. So our A is an x, so it will be x squared equals b squared, which is 27 squared, plus c squared, which is 19 squared, minus 2 lots of our b, which is 27, times c, which is 19, times our cos of our angle, which is 67 degrees. What we now do is put this into our calculator. So we go 27 squared plus 19 squared minus 2 lots of 27 lots of 19 times cos 67. When we put that into our calculator, we get x squared equals 689.1098622. Now we can look at this answer here and go, wow, 689 is a really big side compared to our 27 and our 19. That is where we should recognize that we have an x squared, and what we are trying to find is just an x. So in order to get rid of the x squared and just find x, what we have to do is square root both sides. So when we square root x squared, what we get is just x. And then we have to square root our 689, And what we can do on our calculator for this is we can just go square root and then the answer button, like so, and then equals. And when we press that on our calculator, so square root answer equals, it gives us our answer to be x equals 26.25090212. Now, my biggest tip is to write out all of the decimal places that the calculator gives you every single time. For this one here, as we have already written it up here, you can just write 689.109 ... and that signifies that you're substituting this in here. But for these two, write the whole thing out, because you never know what's going to happen in your calculator and something could go wrong. It's also really important that we write this whole line out so that we show our rounding correct to one decimal place. So we still have to round this, so x will equal 26 point, because we have our second number after our decimal place is a 5, it means we have to round the 2 up to be a 3, so 26.3 centimeters is our answer. Now let's look at our next example. So again, we want to identify whether we should use SOHCAHTOA, the sine rule, or the cosine rule to find the value of the pronumeral correct to the nearest degree. So again, we have the 2 steps to this. And what we can do is straight away we can identify that we have a right angle. So because we have a right angle, we're therefore going to use SOHCAHTOA. Okay, because we have a right angle, use SOHCAHTOA. So for our triangle here, what I'm going to do is I'm going to identify my hypotenuse, my opposite side, and my adjacent. So my hypotenuse is opposite my right angle, which is this side here. My opposite side is opposite my angle, so this side here. And my adjacent side is the side that's left over, which is next to my angle here. So what we can see is that we have O and A. Now, if we look at our SOHCAHTOA, O and A occurs in TOA, so that must mean that we use tan. So we will be using tan theta equals O over A. Now what we want to do is we want to substitute in our values. So our O side is this 8 centimeters here, and our A side is the 11 centimeters here, and we do not know what our angle is. That is what we're trying to find. So we'll have tan theta equals our O side of 8 over our A side of 11. Now what we're trying to find here is theta, so we have to take tan to the other side to leave theta by itself, and so we write tan to the power of -1, 8 over 11. Now on your calculator, everything that I'm putting into my calculator, I'm going to write an annotation off to the side in purple. So on your calculator, you press shift, then tan, then our fraction button, 8 over 11. Actually, I'm just going to write 8 over 11 because you should all know how to put fractions into your calculator. And then we hit equals. And when we do this, so shift tan 8 over 11 equals, we get our answer as a decimal. But what we want is we want our answer to the nearest degree. So the next button that I want to press after my equals is my degrees, minutes, and seconds button, like so. So these are all the buttons that we need to press in order to get our answer. So when we hit our degrees, minute, and second button, we get that theta is equal to 36 degrees, 1 minute, and 38.54 seconds. Now, our question says to round to the nearest degree. So our degrees is here. So just a quick recap on how to round. So we round up to the nearest degree or to the nearest minute if our minute is greater than or equal to 30. So, because our minute is 1, it is not greater than or equal to 30, so our angle of theta is just equal to 36 degrees. Now, it's important to write this out so that you show your rounding, because if you made a mistake in rounding up to the nearest degree or rounding to the nearest degree or to the nearest minute, if you show this step of working here, you will sometimes get the mark if you are doing an assessment task. Moving on to the next example, we again want to identify whether we should use SOHCAHTOA, the sine rule, or the cosine rule to then find the value of the pronumeral correct to 1 decimal place. In the question, it sort of gives it away when it says to correct to 1 decimal place that we're finding a side, whereas back in this example, when it said correct to the nearest degree, it meant that we're finding an angle. So we need to work out what we are going to use. And so what we have here is we have our unknown side of x, we have our another side of 16, so we have 2 sides, and then we have 2 angles, so we have 81 and 54. So because we have 2 sides and 2 angles, we are therefore going to use the sine rule. What we can also see when we look at the sine rule is that we can draw an x when we line up our angle with our side and our other angle with our other side. So we are trying to find the side of a sine rule. So we're going to use a over sine A equals b over sine B. And so what we have is our unknown, which is our x. We have our green matching green matching angle, which will be our A. So on our triangle, we can go ahead and say that this is our side A and this is our angle A. Then what we have is our side of 16, which is our B, and we have our angle of 81, which is our angle B. So this is angle B and this is side B. So if we substitute that in, we'll have x over sine 54 degrees equals 16 over sine 81 degrees. So I'll quickly just show where those numbers have gone for those of you that are unsure. Like so. Our next step here is that we want to get rid of the sine 54. We are just trying to find x, so we want x by itself. So what we have to do is multiply sine 54 degrees to both sides of our equation. And when we do that, we get x equals 16 times sine 54. So we multiply the sine 54 to our numerator and we put it all over that denominator of sine 81 degrees. What we then do is put this into our calculator. So we go 16 times sine 54 all over sine 81. When we put that into our calculator, we get 13.10562389. Now our question said to round to one decimal place, and it's also important to note that 13.1 is in the sort of range of 16. It's near 16, so it means that we are on the right track. So we then just need to round, so therefore x will equal 13.1 centimetres. It's important to include your units. I think if I go back to this example here, I also include my units.